Okay, so today's tutorial is going to be on physics, which is very important for you guys' assignment that you guys have due. So I'm starting from a clean slate, obviously. You know, I only just opened the project, but honestly, here I'll even show you guys that it's completely clean slate. Delete that. Delete that. Oh, did I just delete more than one thing? No, I didn't. So open it up from here. Check that over here. Okay, clean slate. So, the first things that we want to do is obviously, we don't actually need this one, honestly. We want to open up physicsplayground.h, which is a file that I've already included. We don't have to make the file this time. I figure last time, if you guys need examples on how to make the new files, just you can go and check that, and repeat as necessary. And if you really want to, you can delete these and rewrite them. I just didn't see a point in completely rewriting, the basics of a scene when there is already an entire video posted up that explains how to make these scenes. So what we want to do is have that open, and then we want to have physicsplayground.cpp and game.cpp. We want to pin game.cpp. So as you can see, this is exactly where I left off on the last one. You'll notice in first creation, we've already got everything that was in here last time. So if we run it, we can close that folder while we run it. But currently it's creating a first creation scene. So the first thing that we want to do is obviously check to make sure that nothing broke. So this is no changes. I've deleted any, any of the Time64 folders. I've deleted any of that stuff. This is no changes, no nothing. We're just running it to test it. And yeah. Hey, we're just waiting for it to run now. Okay. You can see the key down, key up stuff is still there. It's still got the same link. And that's it. There we go. So we know that this works. So since we already have the file, we might as well physics playground. I've already included physics playground in our scenes thing. And all we want to do here is switch that over to 1. So this will grab the second. So all vectors and lists and arrays in programming, for the most part, I can't think of any specifics, exceptions where this isn't the case. But almost every single one is 0 initiated. So 0 means the first one. So this 1 means the second one, because 0 is a number. So 0, position 0 is this. Position 1 is this. So this is our second item in our list. And that's it. That's all there is to it. So what we want to do now is we're going to run it. Can you guys guess what's going to happen? Because I can. Would you look at that? We have an exception. What happened? Well, we're going to use stack. Call stack. Check out what happened. So backend.draw. So the physics system draw. Weird. It can't access. This doesn't exist. It's because the registry doesn't exist. Sorry, this doesn't exist. The registry isn't like all set up yet. So what we want to do is the first thing we want to do is we want to start writing everything. So this will be just about the same as our last one. And so what we do is, remember what we did in the beginning, and I called this an initializer list. So what this does is this just initializes the base class. This isn't, well, this is entirely required because this is where we create we allocate the physics world. The physics world is a null pointer if we don't do this. So we want this, and then we got our name. So that sets the window name. So so obviously no gravity. This is a top-down scene. Same comment as last time. We just want to make sure, like, you know, do people know? Like it should be immediately apparent, but as everyone here is still starting out programming, it's always very nice to be explicit. It's always very nice to be explicit, and that's always very helpful for people. And so we just created our gravity. We set the world's gravity 0. And now what we're going to do is we're going to have some fun. So this is pretty much like a lot of the same code for the initial, like setting it up. For example, mSceneReg is equal to new entity register. That was there. So attach the register. Oh, I did that wrong. Dynamically allocates the register, which is still accurate. Attach register mSceneReg. Wait, why did that? This is one thing that's bad about IntelliSense. Sometimes when you press tab, it'll have the wrong variable because it won't have caught up to where you're writing. So all it was there was it was at m underscore, and so clear color is the very first one, but it hadn't caught up, and I pressed m underscore, and then I pressed tab, and well, that time it worked. But sometimes it's slow, and sometimes it'll end up giving you the wrong one. You just got to make sure to watch. Sets up aspect ratio. This is, again, still important. For the exact same reason as last time, we actually have this function. This function should really just be in scene. So you know what? We know what we're going to do. We are going to do that. We're going to move it to scene, because we are using it in every single one of our scenes. Thus, this is a function that we really should just include in scene, if I'm honest. So we're going to take this. It should take in the... Yeah, I was right. So if we pay attention here, we'll notice that the aspect ratio is just a saved version of that. So what we need, if we're honest, yeah. So everything here is saved in backend and stuff. So all we have to really do is create a definition. So what I just pressed was Control period. Or you can right click on it, quick actions and refactoring, and then create declaration/definition. That will not create multiple if you've already created it. As you can see, it didn't change anything. And what we're gonna do is we're gonna go back to, because this is something that we've already written, we don't want to create duplicate code. We're gonna go back here into firstcreations.cpp, Control X, find where our thing was added, Control V. Now this is gonna have an error the solution to that error is to simply hashtag include utilities. That's it. That's all. That's all. And so what we can do here now is we can remove this, delete this, and do scene adjust scroll offset. And there you go. Does the exact same thing. It does identical work to what we had. It's just included in the base and we don't have to keep rewriting it. And that's it. That's all. And if we really want to test it, we can actually go back and go to game, set this to a 0, we run it. Oh my. What did I break? What did I break in scene? I do not remember breaking anything in scene. Nothing should be broken in scene. Interesting. Scene is now broken. For what reason? I'm assuming it's this. It's an include loop. That shouldn't be an issue. Weird. Scene very much is not broken. I'm looking at it right now. Scene is very much leading to everything that it needs to lead to. So we're going to do some good old-fashioned debugging. We're going to delete that. We're going to delete that, and then we're going to finish trying to fix this. That shouldn't break it. Why don't I make this virtual? This way it can be overridden. We can make it virtual. We can go to first creations, delete it because it's unimplemented, run it again. Nope. Oh boy. So it would seem that for some reason scene is now unidentified. Oh, here. This is the solution. Never include utilities in the H file. Utilities has an issue, I believe, that makes it so you can't include it in the header file. Yeah, it does. See, because this was broken before. So utilities creates an include loop, essentially, which is a fancy way to say, here, how do I paint on that? So, see, now it runs, and adjust scroll offset works just fine. See? As you can see, it's just so utilities, pardon my poor writing, utilities includes scene utilities includes scene, and then scene includes utilities, which just goes on infinitely, forever and ever. And it's not good. This is not something you want. So the way to get around this, because it's only utilities. Utilities only includes scenes.h. So what you do is if you include it in scenes.cpp instead of, oh, I need to make the thing bigger. If you include it in scenes.cpp instead of, oh boy, not going well. If you include it in scenes.cpp instead of scenes.h, then it is not infinite. It's just this, and then utilities include scenes.h. That's it. That's the workaround. That's why we do it that way. That's why we need to have it in scenes.cpp. It's simple stuff. But basically, what you need to do is go through all of this. So now we have our working. We don't even need to make this virtual. We can run it, and it'll run again. It'll work just fine. But yeah, so now we have adjustable scroll offset as a function. See, it works just fine. So now we have adjustable scroll offset as a function in our scene. So now instead of calling it using the one in here, we just use scene adjust scroll offset. Technically, you can actually just write adjust scroll offset, and it does the exact same thing. But it is preferred to use scene, as it just makes it, it allows, so this way people aren't looking for a function that isn't in here. So when you write scene, it just tells it immediately. It tells people who read it immediately, yo, I should go to scene. Oh, here's the function that I'm looking for. Here's the function that I'm looking at. Now, speaking of which, if you guys are wondering how I do the quick go to, if you hold Control, you hold down Control, you'll see that all your functions now get like a link. They don't do anything without Control held, but when you click on it with Control, it brings you to where the function is defined. Not where it's declared. If you want it where it's declared, you click on that. You click on the name of it. You find where it's declared. So the first click will always bring you to where it's defined. Second click will bring it to you to where it's declared. Now, if it hasn't been declared yet, I believe it'll just bring you to the definition. But if it's not declared, it'll also be giving you errors, I believe. But if we can just write adjust scroll offset or scene. But yeah, that's the gist of it. So now we can continue on. Now we don't have to write adjust scroll offset, which is great, which is amazing, honestly. So now what we're going to do is, so I'm going to tell you now, writing out the physics stuff is very daunting. There is a lot of work that goes into it. This is just aspect ratio, but so writing out physics stuff is a lot of code. So we're setting up our main camera. This will allow us to run the game. So we're going to go back to game just real quick. Switch this back over to 1 because I forgot to do it until now. Also, while you're writing code, remember to be pressing Control-Shift-S. Control-Shift-S basically saves all files. So if you look over here, So there's save all, Control Shift S. So this will save all the changes you've made. Control S will only save the changes in the file you are working in. So if you forgot to press Control S while you were in a file, then it won't be saved at all. And that's not good. That's not what we want. But basically, so we need to create the camera entity. Auto entity equals ECS create entity. And then ECS set is main camera entity true. So one thing I noticed is a lot of the issues that people had, or like bugs that they had, was because they were writing down main camera instead of main player, or vice versa. And so just make sure to read over when you create these. Make sure to read them over. But yeah, basically that is all. So yeah, we just continue on same as last time. Literally the exact same. In fact, we could actually just go copy and paste the code, but it is good to get the practice in. Practice, practice, practice. It is very important to practice when it comes to programming. Same with everything. Same with every path in game dev. Practicing is going to be your best friend. It is very important for you making it through everything. Game dev can be notoriously hard, and so you always need to practice. I forgot to write scroll. So vec4, same as last time, temp equals vec4, 75.f, 75.f, negative 70.f, 75.f. This is just like a screen size that I like. This is it actually comes out to be so here if I open up, we can visualize it. So if I open up Paint, so if you go here, 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 here. So if you hover over what we're about to set, just real quick, ECS get component camera entity dot set ortho size temp, and then we will show, I'll visualize in a second once we can get to the correct line. Camera entity set window size vec2 float window width float. The camera needs to know the window size so that it can adjust appropriately, basically. Get component camera entity dot orthographic. So if you read this, so it asks for the aspect ratio, and then it asks for the left side. So our left is temp.x, which is negative 75. So this is negative 75. So temp.x, left, right, so temp.y, which is 75. So this is 75. Temp.z, which is, again, negative 75, but bottom, so negative 75. And then temp.w, which is 75. And then we have to give it the near plane, which is negative 100. Just means we can, so these basically decide how far, so you know that Z layering that we have, how we could put sprites above or under each other. This just basically makes it so that our scene is a box from negative 100 to 100. And that's it. That's all. But if we look at this, so this goes up to 75. So what this creates is, so negative 75 to 75 is Well, 75 plus 75, because it's 75 minus negative 75, so it's 150. And then, oh, sorry, we already did that. And then, so this is 75 to negative 75, so this is 150. So now it's 150 to 150, and I just like having a box screen like that. It's very nice. This obviously gets adjusted by our aspect ratio of our camera, of our window. So it's technically longer than 150, which is why it doesn't look like a box when we make it. So like aspect ratio will adjust it out to like here, so it keeps the same ratio. It'll make it bigger. It'll make it longer, more rectangle. But this is what our world looks like in points. So there is 75 points from here to here, or sorry, 150 points from here to here, and 150 points from here to here. That's it. That's all. It's just it's I just was doing that for a quick visualization. Now we have to continue from basically we are going to be continuing from over here. We just got to finish, you know, same as last time. So attaches the camera to vert and horizontal scrolls. And so ECS get component horizontal scroll entity set cam and camera entity. So when I write these types of things out in the future for the rest of like these tutorials and stuff, I'm going to be making sure to point out, make sure to watch for main camera, make sure to watch what you're writing, make sure that you're writing, you know, main camera and main player. And I want like this isn't directly at anyone. This is just to make sure that people can catch their errors easier, because it's a very easy error to make. Believe me, I've made that error tons of times and spent time fixing it. It happens to us all. So what we're going to do here is we're going to create a new entity. And this is just our hello world entity, because this is our hello world series. So it's all hello world. Creates entity. This isn't a player, so auto entity equals create entity. Add components. ECS attach component entity attach component. So remember, all we need to make a sprite is a sprite object on a sprite component and a transform component, and now it is a sprite that will render. Set up the components, file name, hello world.png, and just remember, you guys can pause at any point to catch up. I know I type fast, and I'm doing my best to explain as I go and also speak out things, but the point of these videos is so that you guys can pause and continue when you need to, or go back and watch these whenever you guys are making your games or your assignments. Whenever you guys are making your games or your assignments, you guys can come back and watch these videos and learn how to do the basics of the framework, because that is what the point of all of these are. Later on, we'll be getting into more math-specific ones, and we'll be showing off like specific math, and basically using the framework to make the math make sense. Hopefully make sense. We can't guarantee that the math will 100% make sense to everybody, but it should help a lot of people, because a lot of this math is theoretical, and it helps. It always helps to make that math not theoretical and make it like talking about physics. It's a very theoretical subject. It's a real life subject, and you can always like compare it. But when you create things and like do everything, it's very you gotta. It's hard to show certain concepts like the separating axis theorem, which is something don't read too much into that. Just it's something you guys will be learning later on, very later on. But it is a hard topic to conceptualize without seeing it, because seeing is believing. So this is our first box entity, or no, this is our first link entity. So we're gonna create link, and this can be any character you want. You can actually replace it with anything that you put in your last one. So if everybody with all their very unique, which I was very impressed by the way, thank you very much for everybody that posted. I appreciate everything you guys did. I appreciate you guys interacting with the course. But if you added any new characters here, like not Link and other things, please feel free to use them in this. Like by all means, feel free. So right now I'm just gonna create entity. This is our character, so we want it to just we want it to be main player. See, did you see how it went for main camera instead of main player? That is something you need to watch out for, because that can happen. That is something that you need to make sure you are writing set as main player and not set as main camera. Because if you do that, it will mess things up. So we're going to do one thing different here. This is not just a sprite. We're making something physical. We're making something that has mass. We're making something that like exists. So what we're going to do is ECS attach component. We need transform. And so the last thing that we're going to add is ECS attach component physics body. Now this is a curious little toy. This is our physics bodies. Now we use a library called Box2D. I will be linking the documentation for Box2D within the discussion board for this video. The gist is, so this is all this is all stuff that I wrote, not Box2D. So the big thing is that Box2D is very specific. So I have to like set linear velocity and set everything up properly. But you can add any function that you want to your physics body and have it work and have it be usable. Or you can physically write in the Box2D code needed. It's completely up to you, because there is so you can where is it? You can get the Box2D body and then just use that. Or you can write mbody like .apply force and stuff like that. It's completely up to you. That's why it's written like this. This way you can still get the body and still use it and everything properly. Okay, so now we have to set up the components. This is going to be fun. So std string, wait, why did I comment that out? Sets up the components. Now we are only a little bit into this code. This code is going to be a little bit longer. This video is probably going to be around an hour, if you're wondering, and I will include that information in the discussion board. Hopefully, well, when you press play on the video, you'll see how long it is. But just make sure to set aside some time and do the work. So std string file name equals, so you can change this to anything you want. This won't break anything. It is not specific to the link, the link sprite. None of this code is ever specific to one thing. The idea is to make very modifiable code, which is important. Pardon me. So sprite entity dot load sprite file name 40. So this is, I'm making it 40 by 40, but if I remember correctly, we decided to change link. So we made link 80 by 60. So I'm gonna change him here and make him 80 by 60. Because I like him that way. I do enjoy him that way. And now, so ECS get component, sprite, entity, set transparency, 1.f. And then ECS get component, transform, entity, set position, vec3, 0.f, 30.f, 2.f. So this just puts it on layer 2, 30 up in the Y. So now we actually have a bit of work to do. Now, we're going to require two things to be able to set up our physics body properly. First, we want Temp Sprite. So this is just going to hold a temporary reference to our sprite. Think about it as if you have a box. It's a shortcut. Think about it like a shortcut. So if I on my desktop were to right click and create shortcut, that's what this is. That's what I'm doing here. I'm creating a shortcut so that I don't have to write out this code every time. And that's all. That's all a reference is. It's cheaper, doesn't take up as much space, and you will learn more about it later. So this temp physics body, ECS get component, physics body. So we're also grabbing the physics body. Now, there are a few things we can do. So there is no way to visualize our physics bodies, but there is a way that you can make the physics body itself smaller. So technically you can give, oh, I just deleted all that. Technically you can give it any size, but I will show you. So B2, body, oh, sorry, it's lowercase b, B2 body, pointer, temp body. Ignore the pointer. It's not super important for you guys to understand. I cannot explain it as well as I should, as well as it would need to be. So just focus on the fact that it's a container and I'm using it. So tempdef.type. So I am creating, I don't know if you guys know the different types of bodies. And if you don't, you will be learning it in class. So don't worry. So there are dynamic bodies. So a dynamic body just means I can move it around and have it be affected by other bodies. That's it. That's all. So tempdef.position. So this sets the position. So this actually overrides what we set up here. This is more important. This is what decides what we're doing. So float32, which is a custom, if you guys are wondering. I believe it is a custom. Literally all it means, it's float. It's the same as writing float, but it's type deft, which is a fancy way of saying it's like putting a mask. It's like putting one of those masquerade masks on something and pretending it's something else. That's all it is. It's putting a costume on float. So if I click on it, it's just going to tell me it's literally just float. That's all it is. And then double is just float 64. So now we want to do temp body equals. So the physics world is what actually creates every body. So create body, and then we give it the definition of our body. So temp def. And then temp phys body equals physics body. And yes, I'm aware I didn't put a Y in here. I just didn't want to. So temp body float temp sprite dot get width. So this is the size. So what we're doing is we're getting the width. So this is the size of our box body. So this is a box body. So so get width float temp sprite dot get height. Now, so you can do it this way. And then obviously, so vec2, this is the center offset. So where is the center of our object's like mass? Where is it? So obviously I'm just putting it at the center of the object. Sorry, center offset, sorry. So where's the center and how far is it offset from the exact center point of our object? So if we want it in the bottom left corner, it would be negative temp sprite dot get width divided by 2. And then negative temp sprite dot get width divided by, sorry, get height divided by 2. It's simple. It's simple. It's relatively simple. And then his dynamic, false. This is unimportant. This is actually a depreciated call. I honestly couldn't tell you why it's still in here. But it doesn't actually do anything. You can, I'm pretty sure, change it to true and not have it change anything. So one thing here though. So you'll notice with the get width and get height, there's no way to change the get width and get height. Now, you don't always want your physics body to be the exact same size of your sprite. Like, for example, in a Link to the Past, in the dungeon, I am currently opening up the dungeon. So you'll notice that Link can actually walk behind things, as well as like so you'll notice that. So what that means is, so we can open this up, paint.net, and we can draw out the physics bodies. So what that would mean is that the physics body, because you can't walk into this base. This is all you can't walk into. So what I'm going to do is I'm going to change the opacity, make it red, and just start filling things. So that's a physics body. That right there is a physics body. Why did it? Interesting. No idea why backspace is going over it. Shouldn't be. Then there's that, and so on. But in Link to the Past, they had one special thing where, I don't know why I didn't just create a new layer. Yeah, I was right. Okay, so this will be easier. So in Link to the Past, they had a special thing. Enemies actually took up the entirety of the space that they were in. So you would take damage from here. But Link's body, however, just like you could walk over it, so Link could walk in front of this and not have it collide until it reached his feet. So his physics body was basically just his feet. It did not encompass his head. So what you would have to do, and if I remember correctly, this was the entire thing as well. And then this, you could go up to it and like interact with it. And that's another thing. Link could walk right up to the wall, and it would only stop here. Which means there was a physics body here. Which means there was a physics body here. And a physics body here. All of which very important. So the essence of this is that what we've written here is a full-size sprite. Our sprite will be entirely covered by our physics body. But what if we wanted a physics body like this? What if we wanted a physics body like this? Well, I'll tell you. There is a thing that we can do. So what we're going to do is we're going to create these floats. These floats are very simple. It's just, so shrink x equals 0.f. Float shrink y equals, and you can do this any sort of way that you want. But all that I do is go in here and subtract shrink x from get width. Subtract shrink y from get height. This way I can just change these values right here. Subtract 10. So all that's going to do is make it 10 units. So it's going to make it 70. It's going to make it 70 units. And if I subtract 30 from here, it's only going to be 30 high instead of 60. So 60 minus 30. And that's all this does. This just allows you to create physics bodies like what are in your games. Like this. This will allow you to create the illusion of this. And I actually have recreated Link to the Past partially using the physics bodies. My apologies. Using the physics bodies and stuff. I do have a physics version of Link to the Past using Box 2D that I created in this framework. You know, doing everything that I can. Actually, I may. 1 second. Oh, never mind. I don't have them anymore, sadly. I did at one point have a whole bunch of GIFs of Zelda Link to the Past. I have them here, but I can't open them because they're too small. Or too old, sorry. Gyazo doesn't allow you, unless you put them into a collection, you can't save them and go back to them without the link. You can always go back to them if you have the link, though. So, reminder to anyone that uses Gyazo, make sure to save your links. They're very important. Anyways, now we... Oh, that was almost bad. This is why I hate paint.net. So now we have a shrink. So all we have to do is change these if we want to make our physics body smaller or bigger. Now, all we have to do, yes. So this is a thing that we're doing specifically for this body because we do not want it rotating. And this is a pretty normal thing. Make sure you're writing main player here and not main camera. This is an easy mistake to make, but it will get super frustrating when your program doesn't work. Because our main camera does not, in fact, have a physics body. So get body will not work. Nor will get physics body. Dot set fixed rotation to true. So now its rotation can't be changed. It can't be changed by a box it runs into. So if it runs into a box, it's not going to change. It's like its spin is not going to start spinning. However, we do want other things to do that. So what we're going to do here is we are now going to create a few boxes, and we're going to put them in places just to make sure that they do things. So we're going to show off a few different things, and I'm going to show off one specific thing that's going to help with your task at the end of this video. And I will not give you the answer to the task, but I will show you it. So create entity, auto entity, create entity, and then add. We're doing the exact same stuff that we did earlier. Add components, and then attach component sprite, attach component transform, and attach component physics body. Now you can make this anything you want. Yet again, I'm just making it use box sprite because it is an easy box to use. Entity, load sprite, file name. Making it 20 by 20. It doesn't need to be big. Transform. Vec3. So this sets it bottom left, and layers it on, puts it on the same layer as link. Did I screw up? Oh, I did. Puts it on the same layer as link. So now we need to do the exact same thing that we did last time. So keep in mind, there's something cool that you could do with all of this code that you're doing here. So if you notice, there's a lot of repeat code, and there's a reason for that. And the big reason is that I want to show you guys the insides without overwhelming you. But what you can do if you really don't want to like create a camera, you can create a like a function that takes this code, takes in like the scene registry, and then just creates the camera for you. And then all you have to do here is do like, you can just write something like scene create camera, and it'll automatically, and you know, pass in scene reg, and it'll automatically create the camera for you. And that's all. Like that would be all you'd have to write, and that is your main camera entity. That's done. That's finished. You're all done with the camera entity. You don't ever have to write that stuff again. And then you can start creating functions that just create sprites and take in like, you know, scene create sprite. And then this way you can just add sprites to your game over and over again without, like, just by pressing a button or something. You can press the F key and it'll keep creating sprites with the certain parameters that you gave it. So create sprite, oh, I don't know why I did that. But you gotta like you know, obviously scene reg, and then give it the name, so hello world.png, and then give it the width and height of your thing, and then give it the transparency, and then, you know, give it a, you know, vec3 position. And that's it. And this could create your entire sprite, and this would create it, and you wouldn't need any of this code. And you could just sub out these numbers to create different sprites and put them in different positions. And that was all. That would be all you would need. That would be all. And then, like, to create something with a physics body, scene create physics. This is not stuff you have to write, because these aren't like, these don't exist. So create physics sprite. So scene reg, you know, link standby, and then the size of it, you know, size of it, so 80 by 60, and then transparency, and then vec3 0.f, 30.f, 2.f, and then B2 dynamic body. Oh, sorry, is it a B2? Yeah, B2 dynamic body, and then shrink x, shrink y, and then is it fixed rotation, and then you can have parameters after that that check, okay, is this the main player? And this can default to false, but you can also just do true, and then it'll be the main player. it'll save it as the main player. And you can just write this, and this will create your physics. Like, this will create all of this. This will all be done. All by you. That's it. That's all. That's done. That's it. You can just write all of those and just make them like do your bidding. Sorry, I'm going to rewrite this one here and just comment it out. Just leave it here. Just as something to think about. Because this will be the file that you receive in your next tutorial. As you noticed, I'm sure you'll see that first creation, the finished version that we did, was already in here. So create camera. So scene reg. You know, obviously like vec4. You give it the ortho size. Then give it the near, and then you can have like a, you give it window width, window height, and then you can have it like basically, so do you want it to have a horizontal scroll? True. Do you want it to have a vertical scroll? True. That's it. That'll create your camera. That's all. But yeah, I just wanted to like show that off. Like, so that this is a thing that you can do. These don't like your scene like creation doesn't have to be like this long. It never has to be this long. You can easily create scene functions, like base class scene functions. So create functions in scene like we did earlier and make them work properly the way that it all should. But yeah. But anyways, yeah, we can continue with everything now. So obviously we still gotta do, Temp Sprite, entity, and then temp phys equals physics. Damn it. Physics body, entity. And that is all for that. And now we need to write up our box stuff. This is our first box. So we're going to be adding this stuff to it. My apologies, this video is now an hour. It is going to be going on for a little bit longer, just a little bit. Obviously, shrink X, shrink Y, and then B2 body, temp body. So this is just a container for our body, same as last time. Our body definition, so temp def dot type equals B2 dynamic body. So this is also a dynamic body. And for the next box that we create, I'm going to be using a different type. And this type I'm going to explain, and it will help you guys create the task that I have set out for you guys. And will also help you guys with your assignment. Because for your assignment, you are not creating a platformer. You are creating a not a platformer. You guys are creating a side scroller. Sorry, I forgot the word. I have a tendency to forget the word of those kinds of things. But you're creating a side scroller, and you need to be able to create body, temp def, and then temp phys body equals. So because this is a reference, I can just do this and set it equal to it. and this will take the shortcut and update it. Did I spell something wrong? Oh, I never wrote temp phys body. And then it takes in temp body. I also never wrote, I don't know why I keep forgetting the word body. Physics body. So then we're gonna create temp sprite dot get width minus shrink x temp sprite dot get height minus shrink y vec to 0.f because no offset, and then false. Just another thing about the offset. So the offset is the center of our physics body. So if we look back at that picture of this, so the center, here I'll just use snipping tool this time. So the center of this physics body is normally here. But what they've done is shrunk it by about half, by about 3/4 it seems, and then moved that from there down to here. And that's something you're going to need to do. So, and that's something you need to figure out the math for. There is no perfect math that's going to figure that out for you every time. That's going to like automatically figure out how that works and everything. There is no perfect system that makes that stuff work. But yes, so you need to figure out how to make those work. And I'll show off an example later. We're going to be going over an example project that I have going, and that will be one of our tutorials sometime soon. It'll be like a full game that I've been writing, and I'll be showing it off and everything. And we'll be writing some stuff with it. You know, at least that's the plan. It could change. Plan could change. Plans change. So this is bottom left. So I want to create one more box. And this box it'll be our last box. So what we're gonna do is, you know, set up static box. So I'm sure you guys have heard the term static, or if you haven't, you will be learning it in your lecture this week. So I don't know. Okay, auto entity, create entity, add components, and then attach component sprite. And again, this would be a good time to have something like what we had before. So ECS physics body entity, like that function that I mentioned, the create physics sprite. And that is definitely a function that I will be implementing on my own time. I will not be implementing it into your versions. That's completely up to you. The reason for this is because practice makes perfect, and this is more code that you have to write. This is more code that you guys have to learn, more code that you have to understand, rather than just understanding, hey, this is a function, I need to put this, and this in here. The whole point of this is you guys have to learn how to code to be able to make your games. And I know it seems harsh, but it's very important for future years, because eventually you guys need to program your own one of these, complete with everything that I have in here. Everything. Oh, I scrolled up. And get component, sprite, entity, load sprite, file name 2020. Position vec3. So this is on the right side, the back right. -20.f and then 2.f. Same Z layer. Auto and temp sprite. component, sprite, entity, auto and temp. Entity. Oh. Okay. Oh. Temp def. Same thing as last time. The only difference is we're about to write it. Temp def.type equals b2 static body. And then temp def.position dot set float 32 float 32. And then temp body equals dot create body and temp def. So your static bodies, which are something that you guys should learn about very, very soon, they are your walls. They are your immovable objects. Static bodies are immovable. They will not be moved by gravity. They will not be moved by anything. They won't be moved at all. So in the context of a platformer, your static bodies are your platforms, your floors, your everything. And so, and now that we're nearing the end of this, I'm going to give you your task. Your task is to essentially convert what we've written today into a side scroller. Obviously, it doesn't have to be exact, but we're also going to be adding controls, like literally right now. And they're going to be physics-based controls, not the same as what we did before, because those will no longer work. And all we're going to be doing is be setting the velocity, as well as I will be showing you guys how to work with the forces. Keep in mind setting forces. I keep writing physics. I don't know why I keep writing physics body. And that is the end of that. And so last but not least, we need to remember to write this horizontal scroll. If you had issues with writing this last time, please feel free to just copy this from your last from the other thing, because it's very important that this works. So set focus. So make sure that this is main camera, and then make sure that what you're about to write here, get component, transform, main entities, main player. Make sure that what you've written there is the main player specifically. Vertical scroll. One thing you'll notice is if I really want to, I don't actually have to write this second one. I can just do, instead at the end of this line, I do Control C and then Control V, and then do vertical scroll, and that's it. That's all. They're both identical. So when I write using when I just copy over and just write vertical scroll instead, these are both identical lines. Only thing you need to change is whether it's vertical or horizontal scroll. From here, this is our final and last thing. So what we want to do, auto and player equals get component. Now this player get will make sense for our next thing, as we will be creating a basic player controller, and that's pretty cool. That's a lot of fun. I am looking forward to that. And basically we're gonna be making Link run around, and you can theoretically create your own sprites and everything. You're going to need a specific amount of animations for things to work properly. Float speed. So I'm making the speed 10.f, b2 vec2 velocity equals 0.f, or sorry, I always forget you have to do this. v2 vec2 0.f 0.f. And then if input, this is, I mentioned this during our last Q&A session. I was going to be adding a speed up button. Did I forget to oh, that's what I forgot. So utilities includes input. Yeah, input didn't exist. My apologies. Basically, again, we talked about why utilities gets included here, but basically because utilities gets included here, it does not get included from anything else. So what this does is speed times equals to 3.f. And because we're redefining speed every single frame, which isn't that expensive, if I'm honest with you. It gets expensive if you have like 1,000 of these, but specifically for the context of what we're doing, this isn't that bad. Typically, you would want to have a player controller that has speed saved within the player controller. But this just speeds us up if we hold Shift. So if okay, so the first thing that we're gonna do, we are going to if input get key W, or wait, key W, and then if input get key S, and then if input get key, oh, I wrote input get key A, and then if get key D. Now what we can write here is, so velocity plus equals to, so this means they want to go up, so b2 vec2 0.f 1.f, and then player dot get body dot set linear velocity speed times velocity. Now we don't actually need to do it this way, but I'm going to show you guys it this way first, and then I'm going to show you guys a way that works identically, or should work identically. I don't want to jinx myself. I hate giving like absolutes and then having them not work. But so like imagine if you hold W and S at the same time. So the way that this works is it would add 1 and then subtract 1. So all you would be doing here is dot set linear velocity. Oh, dot set linear, nope, velocity. Also, there's a dot set velocity function that you can just do. Does the exact same thing. So speed times veal, but the only issue is that it only accepts a vec3, because it's made to work with the engine rather than box2D specifically. It's made to work with basically any engine that includes like a vector library that they write, because b2 vec2 is a specific, this is b2 means box2D, so it's a box2D vector. So we're gonna do it using the box2D way for now. You could technically just rewrite everything that I've written here and just make it use vector 3 instead of b2 vec2. And then here, so we want this to be negative 1.f 0.f because this is left. So player dot get body dot set linear velocity speed times velocity. Now vel is equal to b2 vec2 0.f player get body velocity speed times velocity. That's it. That's all. So you'll notice we have no way of stopping right now. So setting linear velocity will stay the same every frame. So this is a really bad way of doing it. And this is why I'm going to be showing you guys the way better way after this. So don't write this. So if input get key, this is one way you could write a way to stop. So this means if you're not holding W and you're not holding S and you're not holding A and you're not holding D. That's what that means. If you're not holding any of those, it just does player.getBody.set linear velocity speed times velocity. And all this does is we're writing this because by default vel is 0. So this will allow you to stop. Yeah, this will allow you to stop. This is horrible code. This is code you should never ever think of writing. Don't ask me what went through my head when I wrote it. So you'll notice that I'm slow, and then I hold shift, I'm speedy, and I stop. Now if I close it, delete that, run it again, you will notice I will not stop. Now, what can we do as a solution to this? You'll notice I keep on going. I have stopped holding the button. My hands are entirely up. I have hit A, I hit W, I hit S. So this just sets it. No, I hit W and S, or A and S. There you go. Now it's diagonal. So what's the solution for this? Well, because we're using one variable that gets defined up here and only gets changed if we're pressing the buttons, all we really have to do is player.getBody set linear velocity times velocity. And if no button was ever pressed, it'll just automatically be 0. We can delete all of these from here. We don't need any of this repeat code at all. And that's it. That works now. This will work. Or should. I don't want to jinx it. I'm going to jinx it again. See? So you'll notice another thing. This also I should mention Link's physics body goes outside of his body. The picture that I'm using for him is bigger. So Link is pretty huge. But you'll notice this is the bottom right box that we created. This was static. So you'll notice no matter what I do, no matter how fast I come at it, it does not move. And you'll notice that one's gone now. The only reason it didn't move originally is because my body was colliding with this one. So my body... Oh, I just realized I didn't bring this onto this screen. So you'll notice this is the physics body that doesn't... It's a static physics body. It will not move no matter what I do. It will not move at all. Whereas if I move over here, you'll notice my body is still colliding because the sword goes for much further. So if I keep moving over here, and now if I move up on it, see if we can catch up to it. I believe it is much faster than us. It is very much faster than us. The point is, you know, we can do this as well. We just got to make sure to not accidentally hit it. So see, and then we can, now it's spinning. That was another thing that we wanted. We wanted it to be able to spin. So that one, because we hit it at an angle, it made it spinny. And that is it for this. So you'll notice that static body that we made, if you were to go up here, and so let's create -30. Let's create gravity. And this is all I'm going to show you guys for the platformer. The rest is completely up to you. But you'll notice I'm dropping. And now if I'm still dropping. Now I'm not, because I landed on this box. But if I walk off of it, I'm falling again. Yeah, I'll make it bigger so it's the number bigger. Because Link is so big, his mass is really high, so he takes longer to fall. The box dropped like a rock. Yeah, you'll notice if I run off, I can fight it and just come back. But that's not what we want for the side for the side scroller platformer. But this is technically a side scroller now, because this is ground. So I can make this. If we go here, I'm not going to show you guys how to fully do it, but I will show you guys this. So if we go here and make this 2000. So now it's super wide. And then we make Link, we make him 40 by 30. Now he's exactly half what he was. You'll notice that this box is on it. And we can keep going to the side. And this is a side scroller. However, what I want you guys to do is actually implement like jumps and like jumping, like actual side scroller controls. So like switch it so it uses like apply force for a jump. It's like when you press space, it applies force, and it doesn't use W and S. Like I can't move up and down, because we don't want that. And then you want it to look good and feel good. So like, you want your character to drop nicely. You really want him to drop nicely. So you'll see this. See, that's a nice drop. That's a pretty good drop. So like, I put that on 3000. You'll also notice that if your downwards velocity is too high, I just accidentally activated sticky keys. If your downwards velocity is too high, you won't be able to move left and right unless you're holding shift to counteract that force. But yeah, so this is the beginnings of a very simple side scroller, and all I want you guys to do is finish it. And then this will help with your assignment a lot, because then you can just create platforms, and then you can start messing around with everything. But this is currently still technically top down, it still allows me to move in all 4 directions instead of using jumping. But the point of that static body is that it won't move. It won't move no matter what. Also, it'll always force bodies that are inside of each other outside, and it'll more force the dynamic body outside of the static body first. If it's 2 dynamic bodies, it'll move them both out of each other. And I can't really show you guys that. So see, I caught it just in time. But yeah. That is everything for today's tutorial, though. It came to around an hour and a half. I do apologize for that, but that is regular tutorial time. I'll probably just shorten this week's tutorial. I'll make an announcement for it if that's the case. But yeah, have a great day, everyone. And I hope everyone enjoys the video and gets everything done. And make sure to interact with the discussion board. I make them for a reason. And yeah, have a great day. Bye-bye.